does it go on? Yeah, all right. And these are okay. Alex, it's OBS1. Right, and this one. We will need also another account. You will try to end stream this one. Or this one end stream. Yep, this one end stream and stream dismissed. Right, and copy this. All right, and I need this stream, stream. This one. These to start. Right. Okay. Okay, press this. And many. Right. So whatever we used. Okay. Yeah. Okay, and we'll try to can link. Here. The HD. There's no more. Oh, yeah. What happened? Oh, yeah. I do understand. ร็วHDMI capture. Oh, where is it? Okay, no problem. Open wicket. And open wicket. Okay, and do you need to go to Zoom or what? meeting today. Started right. This one, right? You're gonna need this the clown and this one. Copy and zoom. Right. This one and stream on YouTube. No. Why? Zoom to YouTube. So this one. And right. Später. Alle. Tibian. No. Schneiden. This one, right? We go to your channel. Oh no. We go to go live and manage. Manage. Go to manage. Okay. And this one. Right. No. And education. And this one, the subtitle. All right. And this one. Go to Zoom. Fetish and view shell. Right. Shim start. And this one. You just join the Zoom, right? Join Zoom. Good note. No, not tickets. We're gonna open. We are send the. We are gonna send the. You know. And we go to this driver and lecture EE292 basic. Send it to iPad. Not high. To this one, the second. Okay, and we go to good note open. Important the 292 chapter 2. This one. Right. All right. And yep. Still here. Yep. Okay, you by trade. Oh. 3. Right. Okay, and okay, that's done. Okay, that's done. That's done.
Recording in progress.
Please. Yep. This. Okay. And this one, right? Open. Test 1 2 3 Test 1 2 3 okay. Zoom, there's zoom and pretty okay. What else? We're gonna check this. Right. Switch accounts. And we go to this. This one, we're gonna check the zoom, right? Zoom. Can go to 140. My god, really good. Very good actually. And no. Gonna check the zoom. I think this one. Zoom to YouTube. This is the best one, but it's a different. Okay. And yep. No. Okay, come on. Okay, come on. ไม่มีใครเข้านะโอเค9 วงแล้วนะ test 1 2 3 เสียงมานะครับที่ซูมเสียงมานะ I hope that everything is all right test 1 2 3เครื่องนี้ test 1 2 3 my god show MV right test 1 2 3 1 2 3นะครับโอเคครับก็ไม่ทราบว่ามีคนเข้ามาหรือเปล่าโอเคoh I need to check you in line right line B01 like this okay yeah and this microphone too right you need to open okay what else all right chatting we are gonna copy this OBS2 does it live or not is it live okay it's still live right okay copy this and this one right and this one here right where you can increase the resolution to 1080 okay and this you can increase the resolution to 1040 right okay not sure whether it really works or not this one yeah and this one you're gonna need to stop this okay and this is the zoom channel zoom okayโอเคมาแล้วครับที่ Zoom to YouTube 2 คนครับโอเคsorry okayเวลาโอเคหวังว่าเรียบร้อยนะครับถ้าใครจะเข้ามาที่เรียกว่าอะไรเรียกว่าที่what is that ที่ Zoom นะครับก็เข้าได้นะครับไม่มีก็ผมก็จะปิด panel ของ Zoom นะครับจะไม่เห็นนะครับโอเคมีอลิสานะที่ OBS นะครับไม่ทราบว่าเห็นดีหรือเปล่านะครับแล้วก็ที่ Zoom นี่มีหลายคนนะครับโอเคI think Good morning, everyone. Welcome you to EE292, right? And right. I think we have finished the problem about parallel connection, right? Which is this one, right? เราจบที่ปัญหานี้ถูกไหมครับ ถูกเนาะแล้วเราก็จะต้องต่อใช่ไหมครับ ถ้าผมผิดอะไรไปก็บอกได้นะครับโปรดแจ้งนะโอเคนะครับ Oh I need to moment all right ก็เป็นอันนี้ไปนะครับนะครับเราจบตรงนี้ไปใช่ไหมครับน่าใช่เนาะเราขึ้นตรงนี้ถูกไหมครับปัญหานี้ใช่ไหมเอ่ยน่าจะเป็นปัญหานี้เนาะผมถูกหรือผิดครับเท่าที่จำได้ as I can remember what is going on ผมถึงปัญหานี้เนาะถูกไหมครับถูกนะ all right okay this one and we're gonna stop this because it's gonna consume the internet bandwidth okay ใช่นะครับผมถึงตรงนี้นะตรงนี้นะครับนะครับโอเคถ้าใครจะเข้าที่ซูมก็ทักมาแล้วกันนะครับโอเคyeah in this problem we have to find the voltage V and IT here okay yeah V is the voltage across this one right and I is the current that passes all these impedances all right yeah we will transform these these 4 boxes into many into the impedances okay the first one the first one is the resistor right ถ้าผมผิดยังไงโปรดบอกนะครับไม่ได้จับนานนะครับเซตเครื่องนานมากวันนี้โอเค5 ohm right you can convert it to the box like this okay which is the ZR right and ZR is equal to R right and it's 5 ohm all right this one นะครับชัดนะทุกคนเห็นนะครับ and what else the next one the next one is the capacitor right capacitor here of course in this case we have VM as 10 volts okay VM equal to 10 volts okay according to this one and the next parameter is omega here okay omega is 4 radian per second all right this one and because this is the cosine function, we can say that the phi is 0. Okay, phi is 0. Phi is 0. Okay, and the next one is that we're gonna need to find the capacitor 0.1 farad here. Okay, we will transform it into 0.1 farad, transform it into the impedance, right? So this is ZC. Okay, ZC, and ZC is 1 by J omega C. Okay, it's 1 by J omega is number 4, and here is 0.1. So, and as you know, 1 by J is negative J, right? So you will get negative J 2.5 ohm. All right, something like this นะครับถ้ามีข้อขัดข้องตรงใดก็แจ้งนะครับโอเคนะโอเคnext we will consider the inductor, right? 0.5 Henry. Okay, 0.5 Henry here. Okay, 0.5 Henry, and we will convert it to the impedance box like this, and this is called ZL. Please note that there are two capacitors. This is the first capacitor, and here is the second capacitor, right? So we will say this is C1, right? And here is the C2 will be later, will come later. Here is ZL. There is only a single L, so we will have no subscript for the L at all. Okay, and next one is that we will compute ZL, right, which is J omega L, right? And of course J omega is number 4, and L is 0.5 Henry. We'll get J 2 ohm like this. Okay, the next one, the last one actually, is the second capacitor, 0.2 farad. Okay, 0.2 farad, right? Do it like this, and we will get also Z, but this is C2, right? Omega C here will be C1, right? Okay, and here we will have 1 by J omega C2, because C2 is this value. Okay, C2 is 0.2 farad. Okay, the next one is the computation, right? 1 by มีคนจะเข้ามาที่ซูมไหมครับผมไม่ได้ดูนะมีไหมไม่มีนะครับโอเคJ is J, and omega is 4 radian per second. C2 is 0.2. We would have here half of this, right, which the 2.5 divided by 2, because this is double, okay, this value. So we would have minus J 1.25 ohm, okay, like this. And yeah, we will draw it in the phasor diagram, okay, in the equivalent circuit, right? This one here, okay, what is that? It is 10 cosine 40, right? 10 cosine 40. So we would say this is VS is 10 angle 0, okay, and we would have 3 boxes, right? Oh, right, is that correct? Okay, 3 boxes like this. Here the first box is set R, which is 5 ohm, right? 5 ohm. The second box is the capacitor, which is negative J2.5 ohm. Okay, and here we have the third box, which is the inductor. Okay, this one, and yeah, it's already computed, and J2 ohm, right? This one, J2 ohm, and then we will, oh my god, then all of this is connected to this one, right? JC2, which is negative J2 negative sorry นะครับก็จำไม่ค่อยคล่องนะครับกลับมาออนไลน์ก็negative J1.25 ohm. Okay, this is the equivalent diagram. Today is, I got no here. Today is 10, right? 10.10.2022. Okay. Where is the second chapter? ทำไมผมเปิดไม่ได้นี่เหรอ Okay, yeah, this is the original diagram. Okay, and we convert it to the phasor equivalent diagram like this. Okay, here, this one, and this will appear like this. Okay, and because we want to find the voltage across the whole 3 impedances here, and also the current that flows in this way. Okay, we want to find the current I here, right? What is that? And the voltage also. Yeah, we, okay, like this. Okay, and the next step is that we will combine, okay, all these 3 boxes into a single box. Okay, into set parallel. Okay, not set equivalent. Okay, let's draw the diagram. Here we will get again Vs, and here is Vp, right? V parallel, and here we get set C2, which is negative J1.25 ohm. Okay, and again connected to the source, and Vs is 10 angle 0, right? We need to find Vp, okay, because Vp will be the will be computed from the parallel connection of these 3 impedances. Okay, resistor, capacitor, and inductor here. Okay, Vp can be found. Oh, sorry, not Vp. I'm stupid. It's ZP, not Vp. Okay, ZP. ZP will be the parallel of those 3 boxes, right? The first one is 5 ohm here. Okay, so we get 1 by 5, and plus the second box, which is 1 by negative j 2.5, right? 1 by negative j 2.5. Okay, and plus this one. Okay, 1 by j2. Okay, yes, of course, it's gonna be 1 by 5 plus here we would have j 0.4. Okay, in here we would get negative j 0.5. Okay, j 0.4, yeah, and there you get 1 by 1 by 5 and negative j 0.1. Okay, and yeah, you can multiply both by 10 and 10. Okay, you get 10 and 10, right? So you get 10 above, and number 2 here and minus j. Okay, because the 10 and 0.1 will be number 1. Okay, and here we get 10 and 1 by 5 is number 2. 10 and number 1 will be 10 here. Okay, ถ้าติดขัดตรงไหนก็แจ้งนะครับโอเคไหมผมไปเร็วไปช้าอย่างไรนะครับโอเคall right, that's set P, right? The next one is that we need to reduce this box into a single, these 2 boxes into a single box, and that's called set parallel, right? Set parallel. Okay, with this box, this diagram, okay, we will reduce it to a single impedance. Okay, here we have the voltage source and a single impedance, and this is called set EQ, which is set P plus set C2. Okay, this is set P plus set C2, and here we can find the current I right now. Okay, I was that, and Vs is still the same. Okay, 10 angle 0, right? Okay, we need to find set EQ in this scenario, but set P for us, oh sorry, set P is shown here 10 by 2 minus j, right? We're gonna need to bring it, bring this complex number to the numerator. Okay, we will get set P, which is 10 divided by 2 minus j, and here you get 2 plus j and 2 plus j, right? The complex conjugate, 2 plus j is the complex conjugate of this denominator, okay, 2 minus j. Okay, and once you get something like this, you will have you get later 10 2 plus j, right? And the denominator will be 2 square. 2 square plus minus 1 square. Okay, ขออภัยนะครับแอร์ร้อนนะครับขอลดอุณหภูมินิดนึงครับ Okay, yeah, the denominator, which is 2 square and 1 square. Here, the summation of these two numbers will be number 5, right? So you get 10 by 5, okay, and 2 plus j, right? And yeah, the next one is that 10 and 5, okay, we cancel each other. We're gonna get only number 2. So finally, we get 2 plus j, right? And we get 4 plus j2. Okay. Set p is something like this, but our object is that we need to find our set p plus set c2, which is set eq, right? So set eq will be set p. Set p is this value, right? 4 plus j2 and plus set c2, this value. Set c2 is what we have found before, right? Which is this one, negative j1.25. Okay, you get negative j125, right? So we will get actually 4 plus j0.75. Okay, 0.75. Yeah, it's correct, because this is actually 2 minus 1 minus 5. Sorry for that, I'm too fast. 2 minus 1 to 5, right? So you get 4 plus j 0.75 ohm. Okay, yeah, but it's not this is not finished yet, because we need to prepare it into phasor form, right? Phasor form. What is the common factor we could do that? Otherwise, you need to bring, oh no. Okay, if you go further, set EQ will be 1 by 100, right? And 400 plus j75. Okay, but there is a common factor, which is 25. So we're gonna bring 25 of that, 25 and 100, right? And you have here 16, right? 16, I think. Yeah, 16 plus j3, right? And here you would get 1 by 4 only, and the magnitude will be 16 square plus 3 square, right? Which is 3, and the angle of arctan, right? Arctan imaginary 3 by 16. Okay, and yeah, you would get 1 by 4 of 256, right? 256, I think. Yes, 100 and yeah, 56 and plus 9, right? And here we get arc 10 3 by 16. Okay, here you get 1 by 4 square root of here is 5, right? 265. Okay. 265. Yeah. And arctan 3 by 16. Okay. And because there is the 1 by 4 in square root of 25 and 11. Okay, there is 11 inside that. And ถูกไหมครับเนี่ย is that correct? No นะ 5 no no stupid 25 and oh 5 it is actually number 5. Number 5 and 5, right? And 3. Okay, so there is nothing more, right? So we cannot decompose it at all. Okay, we cannot decompose it at all. Okay, and that's the final result. Okay, this is set EQ. Okay, here is set EQ, and we want to find I, right? In this scenario, okay, we want to find I, the current in this scenario. We will use the Ohm's law. Okay, the Ohm's law says that here you have Ohm's law. Okay, Ohm's law, and it's written as VIR, right? VIR, and the result here can be expressed as I is Vs, okay, divided by Vs, okay, divided by set EQ. Okay, and as you know, Vs is 10 angle 0, 10 angle 0, right? Divided by our set EQ. Set EQ, which is what we have got here, 1 by 4 square root 265. Okay, 1 by 4 square root 265, and arctan 3 by 16. Okay, because we have here 3 and 16 imaginary divided by real. Okay, of course you would get this is square root 5, right? Square root 5, and there you have also 4 of 2 5, right? 2 square root 5 above. You have 4 and 2 square root 5, because you cancel from here square root 5 and divided by square root of 53. Okay, and there you get arctan of 0 degree minus arctan 3 by 16. Okay, and yeah, of course you get 8 square root of 5 by 53 and negative arctan 3 by 16. Okay, and that's the angle 5. So therefore you can find IT, okay, time domain for the current. time domain will be IT, okay, which is IM is 8 square root 5 by 53, and cosine, right, cosine, omega is number 4 here, right? Omega is 4, which is what we have prepared for. Okay, omega is 4 radian per second, so it's 4t, and this angle, okay, minus arc 10 3 by 16, close the parenthesis. You can use the calculator to find this complicated number here. You just use Google for simplicity. 8, right, times square root of 5 by 53. 5 and 53, we get 2457. 2.457, and cosine 4t, and the angle arc10 3 by 6, right? Arc10 3 by 16. You get this value, which is in radians. Okay, you can convert it 2 degrees by pi. So it's 10.62 approximately. Okay, approximately 10.62 degrees, and that's it. Okay, and let's check whether our solution is correct or not. เดี๋ยวเรามาดูนะครับว่าของเราถูกหรือเปล่าถูกไหมครับ ZEQ 4075. Okay, IT is somehow it is right. Okay, yeah, correct. Okay, we get IT, which is 2.45257, cosine 4t minus, okay, minus 10.62 degrees. Okay, that's correct. The unit for the current, I forget it. Okay, ampere. ผมก็ยังลืมหน่วยนะครับ โอเคไหมแต่คุณเวลาสอบอย่าลืมหน่วยนะครับตัดคะแนนได้นะครับ Okay, what else? Now let's move to the next quantity. Okay, you want to find V in this scenario, right? Of course, you know that there will be current here, I, which is already known there, right? I, and they want to find V here. Okay, let's say VP. Okay, VP will be found from the Ohm's law again. Okay, VP will be I times at P. Okay, we will find V across those 3 parallel impedances. Okay, VP. VP, right? VP will be from the Ohm's law again, right? Okay, I set. Okay, if you want to find V, okay, you get the product of I and Z. Okay, I times Z P. Okay, you cannot use ZC1, C2, or ZL1, L2 because this current will pass all those 3 impedances. Okay, you cannot use only ZR, ZC1, or ZL. Okay, you have to use the resounding impedance, which is ZP. Okay, ZP, which is what we have before, is 4 plus J075, right? 4 plus J075. Of course, the current is found as this value, right? Is square root 5, 53, arctan 3 by 16. Okay, we get the first quantity. We get the first quantity. What is that? Okay, this one, right? 8 square root 5 by 53, and the angle here is arctan, or we can approximate it as negative 1062, right, degree, and ZP is 4, right, and plus J 0.75, like this. But it's better if we convert this one, okay, so that we can find the multiplication easily. Okay, this is 4075, right? Of course, we will leave it like that. Okay, first we convert ZP, which is 4 plus J075 into phasor form, right? The common factor here is 1 by 100. Again, 1 by 100. Okay. All right. Set. Oh, no. ZP is not 4 plus J 0.7. ZP is 4 plus J2. I'm stupid. 4 plus J2, not 4 plus J075. 4 plus J2. Okay. And 4 plus J2 can still be converted to phasor. And the common factor here is number 2, right? Common factor is number 2, so we get 2 and 2 plus J. Okay, like this. And now we are going to convert 2 plus J to be phasor, right? 2 and the square root of magnitude, which is 2 square plus 1 square, right? And arctan, again, arctan, the imaginary part of this thing, imaginary part is number 1, right? So we're going to get number 1. The real part is number 2. We have here 1 by 2. Okay, so here you have 2 square root 5, and angle of arctan 1 by 2. Okay, and then we could find VP right now. Okay, we substitute ZP to this location. Okay, 4 plus J2. So right now VP will be I, which is this value. Okay, this one. 8 square root 5 53, and angle minus 1062 degrees. And here you have 2 square root 5, angle arctan 1 by 2, 1 by 2. Okay. Of course, square root 5 and square root 5 will be 5, right? So you get 2 and 8 is going to be 16. Okay, 16 and 5. And by 53, square root of 53. Okay, please note that square root 5 and square root 5 will become number 5 here. 2 and 8 will be 16. Okay. And here you have minus 10, 62 degrees, and plus arctan 1 by 2. Okay. พอได้นะครับ พอได้นะ Okay, we're going to leave this VP in the calculator. Okay, in the calculator again นะครับเมื่อไรมันจะเปิดหลายๆหน้าได้มากกว่านี้นะครับมากกว่า2หน้านะครับ Okay, we have here 16 and 5 will be 80, right? 80 by square root 5353 10.988 988 okay 89 okay and the angle okay angle will be negative arctan 3 by 6 and plus arctan 1 by 2 okay minus arctan 3 by 16 plus arctan 1 by 2 okay you get the result in radiant okay in radiant but you can convert it to the degrees like this degree I don't know whether it works or not no no you have to multiply by 180 and divided by pi 180 by pi 1594 okay 15.945 degrees okay and VT in time domain okay we're gonna express it in time domain VT will be the amplitude okay 10 9 8 8 9 and angle also no sorry not angle should be cosine right cosine 4t plus 15 945 degrees okay and unit of this is volt and that's the answer let's check whether it's correct or not you see VT is like this okay 10.9889 10.989 okay approximately and 40 cosine 14 plus 15 945 15 945 okay alright like this นะครับยังจริงๆผมก็นอนน้อยนะยังไม่ผิดนะครับวันนี้ okay we are still not incorrect okay ยังถูกอยู่นะครับ okay what is that okay we finish this example and let's go to the next topic okay okay you have already seen the parallel connection you have seen the series connection okay and the combination between parallel and series connection right you have already seen it and yeah this is the parallel right next we move to the last topic which is the y delta transformation or you can say it's t and pi transformation okay what happens if the impedances are neither in series nor parallel or in parallel if it's not series and parallel what can we do okay if you unclear about it let's consider this problem. How can we solve this circuit? Is it in series connection or parallel connection? แล้วรูปนี้มันต่ออนุกรมหรือต่อขนานเราจะต้องจัดการอย่างไรดีครับเราจะต้องแบบว่าใช้เทคนิคอะไรเมื่อกี้มันขนานกับอนุกรมผสมกันอันนี้เราจะใช้เทคนิคอะไรดีนะครับโอเคมาเดี๋ยวสรุปภาษาไทยเมื่อกี้นะครับโจทย์ข้อเมื่อกี้เป็นการต่อแบบโจทย์ข้อเมื่อกี้เป็นการต่อแบบขนานกันก่อนนะครับ3อันแล้วก็มาอนุกรมครับ parallel first and then series connection with this thing. Okay, but in this diagram here, what is that then? Is it series connection or parallel connection? อันนี้มันต่ออะไรเนี่ยต่ออนุกรมหรือต่อขนานครับต่ออนุกรมหรือต่อขนานกัน is it series or series or parallel connection มันต่ออะไรนะครับอนุกรมหรือว่าขนานนะครับโอเคมาอนุกรมหรือว่าขนานเลยให้เวลาคิดนะครับพิมพ์ตอบได้ด้วยนะอยู่ YouTube ก็ตามทีก็ตอบได้นะครับโอเคlet me capture all of you to the to our line group โอเคขออนุญาต capture คุณหน่อยนะครับว่าใครมาบ้างวันนี้นะครับนะครับEE292 right should I teach and this one right oh no this you're gonna need this นะครับขออนุญาต capture คุณหน่อยนะครับเผื่ออินเทอร์เน็ตล่มไฟดับกลางคันครับ okay yeah no this one no you need มันเป็นอนุกรมหรือว่าขนานหรือว่าอย่างไรครับ alright ไปแล้วนะก็นี้ด้วยใช่ป่ะ where is the mouse okay we have 3 people here no not 3 many อลิสาย้ายนะมันอาจจะดูไม่ดีนะที่YouTube เนาะokay alright this one rightอลิสาที่นี่แล้วก็ okay one here andนะครับข้อนี้ต่ออะไรครับอนุกรมหรือว่าขนานเนี่ย ต่ออะไรแน่ช่วยคิดหน่อยนะครับโปรดช่วยด้วยนะครับ alright this one โอเคนะแคปเจอร์ไปหมดแล้วนะครับนะครับไม่มีใครตอบนะเพราะว่าไม่ได้อยู่ซูมนะ YouTube มันกลับมาไม่ได้นะครับโอ้2005 alright let's continue our story it's neither series connection nor parallel connection ครับไม่ใช่ทั้งอนุกรมและไม่ใช่ขนานนะครับโอเคไหมความรู้เราก็ยังไม่ถึงนะดังนั้นก็ทำไม่ได้นะข้อนี้ทำไม่ได้ก็ไปต่อครับWednesday okay we have to consider a new type of connection which is called Y connection or sometimes you can call T connection this okay this one can be seen as the letter Y นะครับเหมือนกับตัวอักษร Y นะครับโอเคไหมตัวอักษรตัว Y ภาษาอังกฤษครับโอเคไหมโอเคthis one is like the letter Y in English letter okay and if you pull this one up a little bit okay it will appear like this and this looks like the T letter in English alphabet right so yeah it's the same okay this one is called Y connection this one is T connection but Y and T connection are the same okay how many nodes are there in the Y connection or in the T connection how many nodes do we have we have มีกี่โนดครับรูปนี้รูป Y หรือรูป T เนี่ยมีกี่โนดครับ how many nodes are there in this diagram whether it's 1 2 3 4 5 nodes how many nodes are there in that diagramเท่าไหร่ครับกี่โนดดีครับthere are กี่โนดดีครับ how many nodes there are 4 nodes okay 1 2 3 okay C and D are the same point belong to the same point because there is no element at all so 1 2 3 nodes and another node is the node here at the center this is called the fourth node so there are 4 nodes in this Y connection in the same way okay the T connection is exactly the same as the Y connection okay there are 4 nodes okay 1 2 3 and 4 nodes here okay I hope that you can count it okay you can count it and the next one on the right side is not the same okay it's not the same as the left side the right side is called delta connection okay delta it's delta when the apex or the corner is pointing downward like this okay it's delta if you look in this way okay delta means the letter delta in Greek okay, delta in Greek alphabet. Okay, and here is Y letter in English. Okay, in English. Okay, yeah, this one is called Y. The left side is called Y connection. The right side is called delta connection. Okay, how many nodes do we have in the delta diagram? How many nodes are there in the ธัญนันท์นะเพิ่งมานะครับโอเคไหมธัญนันท์ป่วยเหรอหรือว่าอะไรปกติจะเป็นคนแรกๆที่มาhow many nodes are there in the delta diagram here หรือว่าลืมพิมพ์ชื่อไม่รู้เอาเพิ่งมาแน่นอนเลยเพราะเพิ่มเป็น6 คน how many nodes are there in the delta diagram is it 4 as same as the Y connection มี4 โนดไหมอันนี้ delta มีกี่โนดครับ how many nodes are there in the delta connection of course we have 4 nodes for the Y connection but this is the delta connection it's different okay but you can have also 4 corner like this okay A B C D the same and C and D will belong to the same node right this one how many nodes are there in this diagram มีกี่โนดครับรูปทางขวามือไม่ได้อยู่ห้องจริงก็เลยถามไม่ได้เขียนว่าห้องคุณได้คะแนนน้อยกว่ารุ่นน้องด้วยนะดูแล้วนะครับผมก็ไม่เข้าใจว่าผมสอนไม่ดีหรือว่ายังไงนะไม่มีใครเต็มเลยนะห้องปี2นะครับปัญหาที่1นะครับในขณะที่รุ่นน้องมีเต็มนะทำได้6 คะแนนครับผมก็ไม่เข้าใจว่าอะไรผมเน้นกับรุ่นน้องมากเกินไปหรือเปล่าหรือยังไงไม่ได้เน้นกับคุณครับนะเวลาอยู่ห้องจริงนะครับเรียกออกมาทำเนี่ยควรออกมานะเพราะว่าจะได้เช็คนะครับว่าเป็นหรือไม่ครับพวกห้องปี1ครับถ้าคุณไปดูของเขานะครับแบบว่าจะคุณไปดูห้องเขานะพอเขาจะผมเรียกออกมาทำแล้วเขาออกมาทำเต็มหน้ากระดานเลยแล้วก็ผิดอุตลุดนะครับช่วงที่หน้ากระดานแต่สุดท้ายก็แก้ให้นะครับโอเคมาแล้วคะแนนสอบกลางภาคมาเขาทำได้ด้วยนะโอเคไหมมีเต็มด้วยโอเค how many nodes are there in the right side there will be 1 2 3 nodes okay there are 3 nodes 1 2 3 nodes because we don't have the center point here there will be no 4 nodes okay there will be no the fourth node okay the fourth node doesn't exist so there will be only there are only 3 nodes 1 2 and 3 nodes okay all right again here we have 4 nodes for the T diagram or T connection okay T will be exactly the same as Y connection and if you move this one okay to the left hand side you move this one to the right hand side you get the shape like this okay it's like the letter pi okay this is the letter T in English okay T in English right เหมือนตัวอักษร T ในภาษาอังกฤษ oh sorry H and here it looks like the letter pi in Greek okay the letter pi in Greek what is that just go to Google and we're gonna look for the pi letter Greek alphabet okay Greek alphabet is something like this okay if you compare this connection to to the letter pi in Greek. Okay, you get something like this. Okay, you will see that it looks really similar to that. But this one is delta, right, in Greek alphabet. Okay, this is equivalent. This looks very similar to our pi letter in Greek. So that's why it's called pi connection. Okay, this is called like pi connection. Okay, but it's exactly the same as the y. So the delta connection. Okay, pi is exactly the same as delta connection. Okay, and there are 3 nodes. Okay, 1, 2, 3. Okay, here you have 4 nodes. Sorry for that ครับเขียนอันไม่ได้เขียนอันอะไรนะ iPad นานนะครับมันเขียนไม่ชัดนะครับ and here we have 3 nodes. Okay, we have 3 nodes. Okay, what else? Next, of course, there will be 3 points. Actually, 3 points. 1, 2, 3. 3 nodes. A, B, C, D will be the same, right? A and B and then C and B will be the same. There are three nodes outside. Okay, if we don't count the node inside, we have 3 nodes outside. So sometimes you may want to convert y to delta, or in the opposite way, delta to y. Okay, because in some scenarios you cannot solve the circuit, you cannot solve the problem by using y connection or delta connection. Especially the delta connection would not allow us to find the current or to make the circuit analysis easily. So it's not easy at all to deal with deltas. In many situations, we have to convert delta to y. Okay, in the opposite way, sometimes it's better to convert y to delta. So let's have a look at the way to convert y and delta. This is the formula to convert y and delta. Right? Okay. The way to memorize or remember this one is called cyclic sum by opposite set. Okay, opposite set. Okay, and this one is 2 adjacent impedance set divided by summation. Okay, this is the way to memorize the formula. Okay, you don't have to get into the detail of that. Just use the general way. Okay, and then you can find the conversion formula. Okay, which is little difficult to memorize. Okay, or to remember. Okay, just use this one. Cyclic sum divided by opposite set, or 2 adjacent set divided by summation. Okay, let's have a look at what is that then. No, stupid. Okay, let's have a look at that. What is that? Delta y to delta conversion, right? If you have Y, if you have Y connection like this, okay, if you have connection Y like this, okay, you have the Y connection, and the first impedance is denoted by Z1, second impedance is denoted by Z2, the last one, the third impedance, is denoted by Z with subscript 3. And if you wanna convert this one, the original is the Y connection, right? If you want to convert a Y connection to delta connection, here is the way. Okay, the way is that you just draw it and assume that there will be 3 impedances that appears in 3 impedances that appear instead of the original 3 impedances. Okay, and let's see, yeah, this one, this box, the dashed lines represent the virtual impedance. Okay, this dashed line represent the virtual impedance. โอเคก็คือเส้นปากนะครับจะแสดงเสมือนว่ามี impedance ตรงเป็นรูปเดลต้านะครับแต่จริงๆแล้วมันคือ y นะเราจะแปลง y เป็นเดลต้านะครับโอเค we want to convert the y connection to delta. Okay, let's say this one is called ZA. The lower left is known as ZB. The lower right is known as ZC. Okay, and ZA, ZB, ZC is somehow this. โอ้ทำไมแอร์ไม่เย็นเลยวันนี้ Okay, the original one is Z1, Z2, Z3, right? Original impedances. But we want to convert it to delta connection, right? Like this. And the way to convert is that you have to determine the values of ZA, ZB, and ZC, which doesn't exist, which don't exist, right? But we're gonna assume that it appear in virtual. Okay, so that we can solve the circuit easily. Okay, let's go ahead with ZA. ZA is right here. Okay, ZA is right here, and of course is the cyclic sum. Okay, cyclic sum, cycle sum. It means you just rotate. Okay, Z1 to Z3. In whatever direction. Okay, you may rotate it in counterclockwise direction, or you want also the clockwise direction. You can have any direction. Okay, if we go in the counterclockwise direction, we start from Z1 to Z3, and we're gonna write down Z1, Z3. Because this is the summation, we're gonna have the plus sign. Once you went from Z1 to Z3, next we go from Z3 to Z2. So you're gonna get Z3, Z2. Okay. And the next one is that you have to go from Z2, the last one, from Z2 to Z1. So here you get our Z1, Z2. All right. And then you get this one. Okay, the ratio, and the denominator will be the opposite impedance นะภาษาไทยก็คือ impedance ที่อยู่ตรงข้ามนะครับโอเคไหม ZA is here, the opposite box, the opposite impedance is this location, which is Z3. Okay, Z3, we get Z3. Okay, ZA is in the opposite way to Z3. Okay, right, yeah, somehow it is. So in this figure, In this figure, set A, where is set A is right here. The opposite direction, the opposite impedance of set A is set 1. That's why we get set 1 here at the denominator. And here, the numerator will simply be the cyclic sum. Okay. ขึ้นอยู่กับรูปที่คุณวาดนะครับว่าวาง set A set 1 2 3อย่างไรผมไม่ได้วางอย่างเขานะครับก็วางอย่างเงี้ยมันก็ต้องออกมาเป็นสูตรนี้ครับโอเค now let's consider let's determine set B like this. Okay, set B. The numerator will be the same. Okay, cyclic sum, you start from set 1 to set 3, set 3 to set 2, set 2 to set 1, right? You get set 1 to set 3, set 3 to set 2, set 2 to set 1. Okay, and here you have the denominator. Because you are interested in, you consider set B. Okay, you are interested in set B. The opposite impedance is set 2. Okay, opposite impedance is set 2. So you're gonna get the denominator as set 2. All right, and set C. You have again the same. Okay, you rotate from set 1 to set 3, set 3 to set 2, set 2 to set 1. The cyclic sum at the numerator will be set 1, set 3, set 3 to set 2, plus set 2 to set 1. And the denominator, because you are interested in set C, the opposite impedance of set C is this one, which is set 1. So we're gonna get set 1 as the denominator. Okay, and this is the so-called Y2 delta conversion. Okay, Y2 delta conversion, like this. Okay, the next one is that sometimes you want to convert from, we have already seen Y to delta, right? In the opposite way, we consider delta to Y connection. Okay, delta to Y connection. ตรงไหนนี่อีกแล้วไปเพิ่มหน้านี่อีกแล้วผิดอีกแล้วครับมาครับโอเคhere, right. Okay, the next one is delta to Y connection. We start from the delta like this. Let's say we have here okay, and it's called ZA, ZB, ZC, like this. Okay, and what we want to find is that we want to find the Y connection, like this. Okay, the red one, which don't exist in reality, but we're gonna express it in virtual form, in imaginary. Okay, let's say this is set 1, set 2, set 3. Okay, set is not set 3. All right, if you want to find set 1, set 1, what is that? Note that set 1 stays here and there are two impedances near them. The first one is set A and the second one is set C. Okay, set ขนาบข้างครับมี2อันนะ set A กับ set C นะครับ we are interested in set 1. Okay, set A and set C stay close to set 1, so we're gonna get the numerator as set A, set C. Okay, and the denominator will be denominator คือส่วนนะครับโอเคไหม denominator will be set A plus set B plus set C. Okay, the summation of all those three impedances, set A plus set B plus set C. All right. Okay, set 1 is gone. Let's consider set 2. If we want to find the expression of set 2, set 2 will be, because the impedances that locate close to set 2 are set A and set B. So we're gonna get set A, set B here as at the numerator คือเศษนะครับ numerator คือเศษ and the denominator will be the summation of all these three boxes. So we're gonna get set A plus set B. Okay, summation ครับรวมกัน3ก้อนครับ set A, set B, set C. Okay, cascaded by set A, set B and set C are cascaded by the plus sign. Okay, and now we consider the last one, which is set 3. What is that then? Set 3. Set 3 will be, because set 3 has set B and set C beside it. So you would get the product between set B and set C at the numerator, set B and set C. And here we have you have set A, set B plus set C. All right. Okay. And in the slide, if you want to find set 2 will be the product between set A and set C, because set C is here, set A is here. Create a product between set A and set C. That's why we get set 2, set A, set C. Okay, and the numerator will be, denominator will be the summation of all these impedances. Okay, ได้นะครับ ได้นะ now let's apply this theory to solve the following problem. Okay, this one เป็นปัญหาสุดท้ายของวันนี้แล้วนะครับ โอ้ผมยังไม่ได้เตรียมสไลด์บทที่3ให้คุณเลยเนาะก่อนผมนึกว่าไม่ขึ้นบทที่3เนี่ยแต่ไม่เป็นไรดูก่อนว่ามันจะทันหรือเปล่านะครับ Okay, this problem all right, I'm not sure whether you can see it as delta or y connection. Okay, อันนี้ลูกนี้เป็นเดลต้าหรือว่าเป็น y หรือว่าเป็นอนุกรมหรือว่าเป็นขนาน Does it look like series connection, y connection or delta connection or parallel connection? ต่อแบบไหนครับต่อแบบ y ต่อแบบเดลต้าหรือว่าต่อแบบขนานอันนี้ In figure 13 here ตอบแบบไหนเอ่ยมีใครตอบได้บ้างตอบแบบไหนดีครับตอบแบบอนุกรมขนานหรือว่ายังไงหรือว่า y หรือว่าเดลต้าเป็นอะไรเอ่ยเป็น y เป็นเดลต้าเป็นอนุกรมหรือว่าเป็นขนานครับโอเคactually there are many ways to solve this circuit. Okay, it depends on how you look at this. Okay, whether it's delta or y or whatever you want. Okay, all right, the common thing, the conventional way is that we're gonna take this angle, try to move this one to stay together. It's gonna look like delta. Okay, and we will convert it to y, and then we'll get the result later. All right. Okay, let's solve this problem. Okay, let's solve this problem. What is Vm in this scenario? Vm is 10 volts again. Okay, and what is omega in this scenario? Omega is 4 radiant per second. All right, and what is phi in this scenario? Phi is 0 radian or 0 degrees, right? Okay, 0 degrees or 0 radian is up to you. Okay, in whatever you look at that. Okay. All right. Okay. Yeah. It depends on how you look at this. Okay. Now, ผมไม่รู้ว่าคุณเห็นหรือเปล่านะ Okay. Yeah. Let's go ahead with that. The first one, of course, the 5 ohm resistor. This one. Okay. 5 ohm can be converted to ZR, right? ZR, which is 5. Okay. Ohm. Okay. The next one is the inductor here on the right side. Okay, upper right. 0.5 Henry. Okay. We're gonna write that. Okay, 0.5 Henry, and you're gonna get something like this. Okay, or ZL, right? ZL1, because we have two inductors. The first inductor is here on the right, the upper right. The second inductor is at the lower left. Okay, lower bottom. It's 0.8 Henry. Okay, this is 0.5. Okay, we consider 0.5 Henry. We're gonna get ZL1, which is J omega L, right? Which is 4 and so J2, right? J2 ohm. All right. The third impedance is this one, 0.1 farad in the horizontal way, right? 0.1 farad. 0.1 farad. And you can convert it to the box like this also, right? Is ZC1. 1. This is number 1. 1 by J omega C1, right? If you go ahead with that, it's gonna be negative J2.5 ohm. J2.5 ohm. We do calculate it again, okay? The third impedance has already gone, okay? The fourth is this one, 0.8 in vertical orientation, 0.8 Henry inductor. 0.8 Henry. Okay, and you convert it to the, again, the impedance in the vertical. ZL2, right? Which is J omega L2. And you can see that ZL2 here is omega is 4, L is 0.8, it's going to be 3.2, right? So this one is J3.2 ohm. J3.2 ohm. All right. And the next one is the last one. Okay, the fifth one is 0.2 farad in the vertical way. .2 farad, and that's will be converted again to the vertical impedance like this. This is at C2, which is 1 by J omega C2. Okay, and if you calculate it, it's gonna be half this one, right? It's here we have J minus J2.5 is negative J125 ohm, like this. All right. Yeah, you have already prepared 5 impedances. Okay, for the actual. You have already prepared 5 impedances for the actual diagram. And let's draw the diagram in the frequency domain or in the phasor domain. Okay, let's draw it. Like this, right? Okay. มันจะเพิ่มหน้าให้ถูกหรือเปล่านะครับ Okay. Of course, you have the. Stay with. I don't want it. I want the horizontal diagram like this. Okay. Oh, มันก็ไม่เยอะอีก I got it. No problem. Here we have you have the voltage source, and you get ZR, this location. You get ZL1. Oh, sorry. This is ZR. And here you have ZC1. And then you have ZL2. And here you have ZC2. All right. And like, oh, sorry. Then it's connected further like this. Okay. All right. And here is VS. VS is VM is 10. Omega is 450. So it's gonna be again 10 angle 0. Okay. But in order to go further, we cannot use neither series connection or parallel connection. We're gonna use Y or delta connection, right? We're gonna draw this figure again in a better way, like this. Here you get VS. I just write VS, okay? And then you have ZR. Okay, ZR. And here you have ZL1. Okay, and further you have here ZC1. Okay, and there you get ZL2. Okay, and there you get ZC2. All right, like this. Okay. Do you get confused from the original to the adapted one? Okay, you just join this corner to stay together and you're gonna get here งงไหมครับจากรูปนี้มารูปนี้งงไหมวาดได้นะพอได้นะสี่เหลี่ยมกลายเป็นสามเหลี่ยมมันก็คือรูปเดียวกันนะโหนดเดียวกันนะครับตรงนี้นะโอเค is it okay for you to get that to understand it พอได้นะครับพอได้ไหม oh where is my mouse where is the mouse okay can you get that okay พอได้นะครับพอได้นะ okay and then we will consider only this location this area okay we will convert it to y okay we will consider that area and we will draw it as another separate figure like this okay we are going to use the delta to y connection oh sorry I forget to mention here right I forget to mention this where is that I forget to mention this one is called delta to y conversion delta because we start from delta okay we start from delta the blue one we end up with the red one which is y connection it's going to be called delta to y conversion all right something like this delta to y conversion then for us in this problem we start from delta okay the original connection we will transform it to y connection okay we write it like this let me see it okay here is delta connection we're gonna write it like this okay this is set R this is set R and here we have set L1 and here you get set C1 okay we're gonna express it like this okay okay and we're gonna get like this okay it's time for you now to give a name and give the names to all these three impedances จะเรียกตั้งชื่อมันว่า set อะไรดีครับ set 3 กล่องนี้ okay what should we call it then should it be set อะไรดี set alpha set beta set delta หรือว่าอะไร set gamma set ห้อย 1 set ห้อย 2 set ห้อย 3 set ห้อย a set ห้อย b set ห้อย c คุณ set อะไรดีครับ what should these three impedances be what is the name for that what should it be then เป็น Z อะไรดีครับนะเป็นควรเป็น Z อะไรดีนะ Okay, let's say this is ZA, ZB, ZC. Okay. Oh no, it should not be ZA, ZB, ZC because we have also ZC1, C2. Okay. Let's say we call Z1, Z2, Z3. Okay. Z1, Z2, Z3. So what is the expression for Z1? Z1 หาได้ไง Z1 just locates here and there are two impedances beside it, okay, which are ZR, ZL1, right? So we're gonna write ZR times ZL1 divided by the summation of all these three impedances, which are ZR plus ZC1 plus ZL1, like this. Okay, and you just substitute the Z RZL ZC1 too. Okay, what we have prepared before, ZR is which is 5 ohm. Okay, 5. ZL1 is L1, right? It's J2, and divided by, okay, divided by these three impedances, which is 5, okay, 5 plus ZC1 is this thing, minus J2.5, okay, and plus the last impedance, which is ZL1. ZL1 is J2. All right, and you get J10, okay, J10, and you get, sorry for it, you get J10 and here 5 minus J 0.5. all right, and if you multiply the whole thing by 10, okay, 10 and 10, and 10 here too, okay, you would get J100 and 50 minus J5. all right, and you can put the number 5 in front of that. You're gonna get J100, 5 and 10 minus J, okay, and there you get 10 plus J and 10 plus J. Okay, in order to flip this one, okay, flip this one up, we have to multiply by the complex conjugate. Okay, and there you go, because 5 and 100 is going to be J20, right? You will get J20, and of course above there you get 10 plus J. And here at the denominator, you're going to have 100. Okay, 10 square. Plus minus 1 square, right? It's plus 1 square. It's the complex conjugate for that. Okay, minus 1 square. All right. Or 1 square. I'm sorry for that. It's yeah, no problem. My God, stupid. Yeah, here you would have J10, 10 by that, right? If you distribute J into that, you're gonna get 20 by 100, and number 1 is 101, right? And here you get minus 1 plus J10, right? Okay, you distribute J into the factor, into the parentheses here. You have J10, which is right here. J and J will be -1 right here, okay? And this is set 1. All right. Now let's move to set 2. You have already got the value of set 1, which is this thing, okay? 20 by 101. Oh my God. Okay, 20 divided by 101. And the second impedance, which is set 2 here. Okay, set 2. Let's open another page. Okay, we're gonna compute set 2. Set 2 locates just here, and beside set 2, there are set R and set C1, right? Set R and set C1. So set 2 will be set R times set C1 and divided by the summation of all these 3 things, okay, 3 boxes, and that's set R plus set C1 and plus another impedance, which is set L1. Okay, set R, of course, is what we know before. Set R is 5. All right, here set R is 5. We get here 5. Set C1 is right here, minus J2.5 or negative J2.5. J2.5. And of course, the summation here of these 3 impedances is what we have already done here. Okay, 5 minus J 0.5, 5 minus J 0.5. Okay, and again, we are gonna multiply this thing by 10 and 10 for simplicity. And there you get 5 and 25, right? So it's gonna be 125. Oh, sorry. You're gonna get minus J 5 and 25. Okay, and here at the denominator you get 50 minus J 5. Okay, and you can distribute number 5 at the denominator out of this factor. You're gonna get minus J 5 25, and 5 in front of that is number 10 minus J. Okay, and you can see that you can cancel 5 and 5, and again we need to multiply the complex conjugate. It's 10 plus J and 10 plus J. Okay, yeah, 10 plus J and 10 plus J. Here you get negative J 25 and 10. Oh, sorry. 10 plus J divided by 10 square plus minus 1 square. Okay, and you're gonna get, of course, you would have 25 divided by 101 in front of that, and minus j, and j will be number 1, right? 1. And here you get negative j10 minus j10. All right. And there you go, okay, because we cannot do anything more. And here is set 2. All right, set 2. Oh, stupid. Okay, set 2. We need one more page. Okay. Now let's compute the third impedance, which is set 3 right here. Set 3. Set 3 will be, because set 3 locates here, and on the right side we have set A1, on the left side we have, there is set C1. So set 3 will be the product set A1 set C1 as at the numerator. So you get here set C1 set L1. Okay, yeah, and the denominator will be the product. Okay, product set R plus set C1 plus set L1. All right, and once you leave the value for that, right? Because we have already prepared set C1. Set C1 is minus J2.5. Minus J2.5, and set L1. Set L1 is J2. All right, and there you get the numerator, which is the summation of all these three impedances. What we have done before is that the summation of all these three impedances is 5 minus J2.5, 5 minus J0.5. Not 2.5, okay, 0.5. And the way to do is we need to make it as the integer, right? We multiply above by 10 and the lower by 10. You're gonna get what is that? Negative j, and j will be number 1, right? So this is 5. 5 and 10 will stay there at the numerator, number 10. In here you get 50 minus j5, 50 minus j5, and you extract or try to bring number 5 out of these parentheses. You're gonna get 5 and 10 and 5, 10, oh sorry, minus j. Okay, and again we can cancel number 5 and 5 here, and in order to bring it up, you multiply by 10 plus j again. 10 plus j. Okay, there you get 10 in front of that, and 10 plus j. 10 plus j. All right. 10 plus j. All right, and the lower will be the summation of 10 squared minus 1 square, right? So we have 10 square plus minus 1 square, and then you get 10 by 101 and 10 plus j. All right. Okay, this is set 3 after the conversion here, set 3. Okay, Once we get already set 3, we are gonna remove the delta connection and we would have only y connection, set 1, set 2, and set 3 like that. Okay, the figure, the diagram will change now to we would have the voltage source here, right? And you're gonna get set 1 right this, okay, and here you get set 2, and there you get set 3, and another one is set C2, set L2 right here. Okay, we get our set C2. We have here set C2 and bring it back to the voltage source. And here is our set L2, okay, like this. Okay, now we can draw this figure again in this way. Okay, we can draw this figure. This is Vs, right? Here Vs, again Vs, and here we have the voltage source in set 1, right? And we can draw it like this. And here is set 3. Or set 2. And here you have set L1 or set L2, sorry. And there you have set there you have set C2. All right, like this. Okay, the figure now will turn into this diagram. Okay, like this. Okay, like this. Okay, the way to solve this figure is that we're gonna need to combine these two impedances into a single impedance. Okay, and on the right side, okay, we can combine again to a single impedance. Okay, let's draw it again. You have the voltage source like this. Okay, set 1, and here after the combination you get set. Okay, let's say this is set 4, this is set 5. Okay, let's say this is set 4 and here it's set 5, and this is Vs. All right. Okay, so what is set 4 then in this scenario? Because this is the series connection, set 2 and set L2, right? This is our set 4. Okay, this is set set 4, and here is here is set 5. Okay, our set 4 will be the combination of set 2 and set L2. So set 4 will be set 2 plus set L2. Okay, our set 5 will be the combination of set 3 and set C2. So it's going to be set 3 plus set C2. All right. So let's go ahead with that because we have already found set 2, right? Set 4 is set 2. Where is set 2? Set 2 is this one. 205. 25 by 111. Or 101 and 1 minus J10 plus set L2. Where is set L2? Set L2 is prepared here, okay, which is the J3.2, okay, plus J3.2, okay, that is or set 4, okay, yeah, what else? Yeah, that's set 4. Okay, just leave it like this. We're going to use the calculator soon, I think, because the number is quite complicated. Okay, what else? Parallel to what about set 4 in after the calculator? Okay, we're gonna use set 4 like this, and set 5. What about set 5? Set 5 is, or set 3. Where is set 3? We have already got the value of set 3, which is 10 by 101 and 10 plus C and plus set C2. Set C2 is, where is set C2? Set C2 is over here, which is negative J1.25 minus J1.25. All right, we will use soon the calculator. Okay, we will use soon the calculator. Okay, okay, 25 101. 25 by 101. 1 minus J10. 1 minus I times 10. And plus I times 3.2. 3.2 is, what is that? Yeah, it's a complex number. As the 0.2475 plus J 0.7248, something like that. Okay, what about the set 5? Here you get 10, right? 10, 101 and 10 plus I and minus $1.25. Okay, and we get 0.99 and plus J 1.35 or something like that. Okay, yeah, or it's better to use the better calculator. I'm sorry for that. Let's use Madonna input. Okay, set 4, right? Set 4. Uh, 25 by 101 times 1 minus I times 10 plus I times 3.2 and set 5 10 by 10 by 101 and times 10 plus I 10 plus I and plus I times the negative 1.25. Okay, let's see the answer. Huh? What happened? Okay, we need to go to, sorry for that, to source here. Okay, we have to leave it here. Let it run. Okay, 0.24752. Okay, this one 0.724 like this, and 0.99, and this is negative. Sorry, this is negative. Is that correct? Yeah, it's negative actually. Sorry for that. It's negative 115 blah blah blah. Okay, 115 and negative like this. Okay, what else? That's set 5. Okay, in this figure we can further combine these two impedances because these two impedances are connected in parallel connection, right? This is parallel connection. Okay, parallel connection, and let's say this is equal to set P. Okay, set P is set 4 parallel set 5. Okay, now we're gonna find set P in this scenario. Okay, set P could be found from 1 by set 4 plus 1 by set 5 in raises to negative 1. So you're gonna get you get 1 by set 4, okay, which is that number, okay, 0.2475 and plus J 0.7248. J 248. Okay, 1 like this, and you have to add it to another one, which is this number 0.99 and minus J115. Okay, and use the calculator to find that. Okay, where is that? Okay, set P, right? 1 by set 4 plus 1 by set 5 and raises to -1. Raises to -1. Okay. Oh my god. Set P. My god. Without the blank or space bar. Okay. Yeah, set P appears to be 0.67194 plus J058102. Okay, that's set P. Okay, right now we have the diagram like this. We have the diagram like this. This is the water source, right? Vs. And here is, what is that? The first box. The first box is set 1, right? Set 1. Right here, set 1. And here is set P, right? We get here set 1, and the lower one is set P, which is what we have just found here. Okay, set P. And okay, it's returned to another side of the water source. And you can combine these two boxes into a single box like this. Finally, you're gonna get set EQ. Okay, the last box like this. Okay, and there will be I, right, that flows in this way. There will be also I in this way, which is unknown. Okay, I is unknown in this way. Okay, anyway, set EQ, what is that then? Set EQ. Set EQ is the series connection between set 1 and set P. This is the series connection. Okay, so in series connection, we're gonna combine these two boxes, two impedances into a single box like this as the summation, right? So it's gonna be set 1 plus set P. Okay, what is set 1? Set 1 is what we have got before, right? Set 1 is equal to this, right? 10 by 101 and -1 J10, right? Set 1 is 20 by 101 minus 1 plus J10 and set P. Okay, set P is somehow is set P is something it is 0.67194 767 194 plus J 058 102. Okay, yeah, and there you get the summation, right? You can use the calculator again. Set 1. Let's introduce set 1. Let's introduce set 1 like this. Okay, set 1 is here 20 by 101 times minus 1 plus I times 10. Oh, sorry. small I like this, okay, and set EQ. Okay, set EQ will be Z1 plus ZP, right? ZP. Okay. We'll see what is set EQ in this scenario. Okay, let's calculate it. Okay, there you get, where is my pen? Oh, the pen is right here. KR วรัญญาหัวหน้าห้องไปไหนมาเคยไหมครับเพิ่งเข้ามาเหรอ KR ZEQ ZEQ will be 0.47392 plus J 256122. Okay, but in order to find I, right, because I will be the division between the voltage source Vs by ZEQ. In order to make the division, ZEQ should be expressed in phasor form, right? In phasor, we're gonna find the phasor of this impedance. Okay, let's try to find ABS ZEQ. This is the magnitude, and arc, which is the angle, EQ times 180 by pi. Let's see, what is that? So we get ZEQ in phasor form as 2.6047 and angle 79 5168 degree. Okay, and because we're gonna find I, right? Because I is what they want to know. I is Vs by ZEQ. Okay, Vs is, as we know before, Vs is 10 angle 0, 10 angle 0 degree. We're going to divide by ZEQ, which is what we're going to get here. Okay, we just got there 2.6047 and angle 795168. Okay, of course I will be 10 by this number, right? That's I. Okay, this is that EQ. Oh, sorry. KRI will be first thing. Okay, we copy this one. Set EQ phasor. Set EQ phasor is this number. So we're gonna get this one. This the negative one, right? Absolute value of this thing divided by 10 divided by this value, right? And here is the negative angle, right? So I is something like that. I will be 3, 8, 392 and angle 79 5168 degree, like this. And in terms of time domain, because everything has to be expressed in time domain, IT will be 3.8392 and cosine, right? Cosine, the angle, the omega, the angular frequency is 4, right? So it's 4t minus 79, 5168. I think it's not correct. Unit of current is ampere, and that's the answer. Let's check whether it's correct or not นะครับไม่รู้ว่าถูกหรือเปล่านะครับโอเคมาเรามาดูกันครับ Let's check whether the answer is correct or not มาดูนะว่าครับตอบถูกหรือเปล่าผมพาคุณมั่วแน่นอน Yeah my God exactly okay 38392 38392 cosine 4t cosine 4t minus 79 517 5168 okay and that's it for this problem okay is it too difficult for you ยากไปไหมครับข้อนี้12คะแนนนะครับสำหรับสอบกลางภาคนะออกแบบนี้แหละไม่เปลี่ยนอะไรด้วยเปลี่ยนแค่ตัวเลขนะครับโอเคไหมกองเกิงตัว R ตัว L ตัว C ตำแหน่งเดิมเป๊ะนะครับโอเคไหมเปลี่ยนบางสิ่งบางอย่างแค่นี้ครับอันนี้โหโชคดีมากผมเมื่อคืนผมก็นอนน้อยนะนอนไม่กี่ชั่วโมงไม่ผิดเลยนะครับโอเคไหมโหสุดยอดมาก alright ดีนะไม่ผิดนะครับไม่งั้นพาคุณหลงงงสงสัยนะครับ alright we still have 40 minutes โอเคเรามีอีก40นาทีนะครับเดี๋ยวผมไม่ได้เตรียมบทที่3ไปเลยขออนุญาตเตรียมไฟล์บทที่3ให้คุณนิดนึงได้ไหมครับหรือว่าจะเลิกเลยหรือว่าไงให้คำตอบมานะครับโอเคไหมงั้นก็ให้ผมเตรียมทำไฟล์แป๊บนึงแล้วกันนะครับเดี๋ยวส่งสไลด์บทที่3ให้มันเสร็จแล้วแหละแต่ว่าแค่ใส่ปีพศแค่นั้นเองนะครับโอเคไหมใส่ปีใส่เทอมให้ถูกต้องนะครับโอเคwe're gonna move to the third chapter okay we finished the second chapter okay the answer is right here it's already computed in you can check everything okay the value of set L1 set L2 set C2 set 1 set 2 set 3 set P1 set P2 which is set 4 set 5 and this is set parallel this is set EQ set EQ is 0479 okay 4739 the same thing 2.5 blah 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 okay the same exactly the same 26048 okay exactly the same นะครับถูกเป๊ะเลยนะครับเพราะว่าอันนี้เป็นคำตอบที่คำนวณไว้ตั้งแต่นู้นปีที่แล้วนะครับนานแล้วนะครับโอเคปีแล้วหรือว่าเทอมที่แล้วจำไม่ได้ครับlet me prepare the third lecture the third chapter โอเคขออนุญาตแก้ชื่อปีนิดนึงครับไม่คิดว่าจะหลุดขึ้นบทที่3ได้แล้วนะโอ้สุดยอดมากเก่งมากครับผมก็ไม่คาดฝันนะครับว่าจะหลุดแล้วนะบทที่2ซึ่งเป็นบทที่ยาวมากๆนะครับ Okay we move to the third chapterนะครับระหว่างนี้คุณก็เบรกไปก่อนก็ได้นะครับเดี๋ยวผมเตรียมสไลด์แป๊บหนึ่งครับ this one and the second chapter this okay and leave it there let's compute this second chapter is right here I'm gonna need this okay here too. Huh? I can't find. Cái này the third shutter. Huh? Đơn đề. Oh, with S2. So that's my God, what happened? Bit late. Okay. And yeah. All right. Okay. Ah, my God. Why? Existed. Oh, ทำไมรันไม่ได้ Yes, sir.ได้ Okay. The B01, 03, and so forth. Okay, and date is today. She's the set, no, October 10. October 10. October 10. And academic year 1. In the description is like this. On site online. Group config. like this, but we need the figure. We need a figure from picture. Second, this and YT logo. Okay, yep. Okay. Define control. Yep. YT logo. YT logo. YT logo อันนี้มาไม่หมดมาก่อน lecture affiliation. Where is YT logo? YT logo, lecture affiliation. Yes, these. Stay with lecture tab. All right. Oh, semester academic year. We shouldn't have lecture date. The lecture date is not necessary. It's too long. Yeah, lecture date is not necessary. Okay, lecture semester only. Yep, and space is only one. No. 6. All right, and 4, 5. Oh, I miss it. All right. Okay. 5 would be very fine. Okay เรียบร้อยนะครับเดี๋ยวส่งไฟล์ให้นะครับ chapter 3 right นะครับส่งไฟล์นะครับin iPad โอเคdata yes chapter 3 this one โอเคมาแล้วนะครับchapter 3 October 10 right จบบทที่2แล้วนะครับเดี๋ยวเราขึ้นบทที่3นะครับอันนี้เป็นตอนเรียนแรกนะครับคุณขึ้นบทที่3นะครับ oh no chapter 3 voltage where is that where oh my to iPad data this 2 voltage KN to EE292 in chapter 3 where is that not here chapter 3 why ทำไมหาไม่เจอครับไม่ก่อน why yeah งงครับว่าทำไมไม่มีครับโอเคmoment okay are we gonna hold by using iPad right open by good note yeah okay right here today is 10.10.22 okay all right let's start the third chapter okay the title of this chapter is voltage we are going to talk about the potential difference เราจะเรียนบทที่3เรื่องแรงดันไฟฟ้านะครับ okay this is for section B01 okay but this slide is valid also for B03 B04 okay the content in this chapter is something about maze analysis okay we will talk about the theory okay how many steps are there in maze analysis and we will apply the theory of maze analysis to tackle the real problems real diagrams and we will consider difficult situation when there is current source because maze analysis is suitable to voltage source okay maze analysis is happy with voltage source what is voltage source? Voltage source is somehow like this one, right? Plus and minus. okay, or in AC circuit you would have also something like this, right? VST blah blah blah, right? This is the AC, this is the DC, right? Okay, yeah, there you go. You have DC and this, but in this chapter we will talk about the simple case, okay, the DC. But the theory of the maze analysis is also valid for the AC case. All right, you can do it by your own, okay, for the AC case, okay. But in this chapter we will consider only the simple scenario, which is direct current, okay. What is the procedure or the theory of the maze analysis? You need to be able to find the number of nodes, the number of matches, or the number of loops in the diagram, okay. And assume that if we have n loops or n matches, we need to assign a name, okay, introduce the name to the maze currents, for example, I1, I2, I until In, because we have n matches, okay. The current I should be assigned to each loop, okay, for n matches. And we are going to need to assume the direction of the maze current I1, I2, In to the n matches. And after that, we are going to apply the KVL. You know KVL, right? From the first chapter, sum V equal to 0, right? That's KVL. It's the circulation of the current, okay. You can apply the KVL later. I will show you in the real problem, okay, in the application. We need to express the voltages in terms of maze current by using the Ohm's law. Okay, and after that we're going to solve those in simultaneous equations to obtain the unknown maze currents, okay, of the several I. Okay, and that's it for the theory or the procedure of the maze analysis. Okay, we still have 20 minutes. Let's consider the first example. Like this, how many loops are there in this diagram? รูปนี้มีกี่ลูปครับพิมพ์ตอบเลยรูปนี้มีกี่ลูปเลย We're gonna solve this problem, right? I'm gonna open รูปนี้มีกี่ลูปครับรูปนี้มีกี่ลูปขออนุญาตแคปเจอร์หน้าจอนิดนึงครับมีมาเพิ่ม2คนนะโอเคส่งสไลด์ไปให้แล้วนะครับสไลด์บทใหม่นะเดี๋ยวอัปโหลดเข้าไปที่ Google Classroom ด้วยนะครับ right is that correct no this rightมีกี่ลูปครับรูปนี้นะครับมีกี่ลูปเอ่ย If you cannot determine the number of loops, then it's really difficult to go ahead, or even it's impossible. Oh no. This. Okay, in this figure there are two loops, right? There are two loops in these diagrams. All right. So the capital N is equal to 2. The capital N is equal to 2. Okay, there are two loops. Okay, there are two loops in this diagram, and we need to draw it. We need to draw this diagram. We have to open the third shutter. Voltage, this one. Okay, let's draw this circuit again. You have here plus and minus 15 volt. Here you have 5 ohm here. You have 10 ohm. You have plus and minus 10 volt. This and or this one. Okay. Here is 5 ohm, 10 ohm, 10 volt, and 6 ohm, 4 ohm. And the current will flow in this direction. That's I1, that's I2, and here below is I3. Okay, what they want to know is what is I1, I2, I3. Okay, what is I1? What is I2? and I3 นะครับ คนไหนทำข้อสอบมาไม่วาดรูปนะครับ จะคูณด้วย 0.75 นะครับโอเคไหมไม่รู้เรื่องนะครับว่าคุณกำหนดทิศกระแสอะไรยังไงนะครับโอเคไหมโปรดใช้มาด้วยนะครับโอเคไหมโปรดใช้สิ่งต่างๆนี้มาด้วยครับ KR โปรดวาดรูปมาด้วยนะครับ KR next we will assign the current, right? Assign the current and the current name too. Okay, we need to introduce the current name and the direction. Okay. First, introduce the current name and their direction. Okay, because n is equal to 2, because n is equal to 2, so there will be two loops, right? And what are directions do you prefer? You want it to rotate in this clockwise direction, or in counterclockwise direction. What direction you wanted? คุณต้องการแบบไหนครับพิมพ์บอกผมนะครับผมจะได้แสดงวิธีทำให้คุณนะครับโอเคไหมยังไงมันก็ออกมาคำตอบเดียวกันนะครับไม่ว่า clockwise หรือว่า counterclockwise นะครับนะครับคุณต้องการแบบตามเข็มหรือว่าทวนเข็มนาฬิกานะครับลูปซ้ายเป็นตามเข็มตามหรือว่าทวนหรือว่าตามทวนหรือว่าทวนตาม Okay what do you want then for possibility the first one clockwise and clockwise the second one clockwise and counterclockwise the third one counterclockwise and clockwise direction the fourth one is counterclockwise and counterclockwise as well คุณจะเอาช้อยไหนครับ1 2 3 4รูปซ้ายรูปขวาครับผมจะได้แสดงวิธีทำให้คุณโอเค What do you want then clockwise direction เลือกมาครับ1 2 3 4เนี่ยเลือกช้อยไหนผมจะได้ทำให้คุณถูกนะครับให้ถูกใจคุณนะครับWhat do you want then ช่วยพิมพ์บอกนะครับอยู่ YouTube นะ5 คนนะครับตอนนี้นะโอเค What do you want then Oh no did ต้องการแบบไหนครับ clockwise หรือว่าตามเข็มตามทวนตามหรือว่าทวนเลยมันไม่ได้อยู่ห้องจริงเนาะมันก็จะพิมพ์บอกมานะครับพิมพ์บอกที่ YouTube 1ค่ะสถิตานะสถิตาบอกว่า1นะคนอื่นไม่มีใครว่านะโอเค clockwise and clockwise okay we will go ahead with clockwise style clockwise and clockwise so this one and this one right clockwise CW okay clockwise and what is the current for the first one you first okay let's say for simplicity this is I1 this is I2 all right okay we have I1 I2 like this and what is the relationship between I1 small I1 and I2 I3 by looking I1 the capital I1 here is what is the relationship to the small I1 I ใหญ่1กับ I เล็ก1ว่าไงThe capital I1 is exactly the same as the letter small I1. And what about I2? I2 is exactly the same as small I2. Okay. And what about I3? Because I3 is going down, right? I3 flows downward. So I1 is going down, I2 is going up at this branch. So I3 will be I1 minus I2 because I2 goes in the opposite way to the capital I3. A small I1 goes in the same direction as the capital I3, so it's going to be positive here. Okay, I2 goes in the opposite direction, so we have negative value there. All right. Okay. So we need to find I1, I2, I3, and we finish this problem. Okay. Okay, let's start to go ahead with that. In the first loop, like this. In the first loop. In the first loop. We can find the KVL, right? You start from this location. You go up, okay, you walk, and you pass the negative polarity of this voltage source of 15 volts. So you're gonna get minus 15. Okay, and you go further, you can go right. Here you go right, and you go with I1 and you pass 5 ohm. So it's gonna be I1 times 5 ohms. Okay, and after that I1 goes down and it passes 10 ohm. Okay, it passes 10 ohm, but there is not only I1. Okay, there is I2 going up, so we need to write here I1 minus I2, because I2 flows in the opposite way, opposite direction to I1. Okay, so this is times 10, because both currents pass the resistor of 10 ohm. And after that I1, okay, you go this way. You go like this. You left this. Okay, and then you go here, right? You left this. Now you will pass the positive side of this voltage of number 10. So we're gonna write down plus 10 and equal to 0. All right, and that's for the first loop. Okay, you need to manipulate this equation. It's minus 15 plus 10 and plus 5 I1 plus 10 I1 and minus 10 I2 equal to 0, right? And there you get minus 5 and plus 5 I1, sorry, yeah, plus 10 I2 minus 10 I2 equal to 0. Okay, and you find the most common division number of 5, 5, 10, 10. So it's number 5, right? So you multiply the whole equation by 5 times the whole equation. Okay, you're gonna get minus 1 plus I1 plus 2 I1 plus 2 I2 equal to 0, right? And you can move number 1 to the right hand side, and here you get 3 I1 and 2 I2, right? 3 I1 plus 2 I2 equal to 1. Equation number 1. That's it. Okay, in the first loop we can get something like this. In the second loop, you need to start from this location. Okay, you start and you go up. Okay, in the second loop, the KVL will say that you go up here, you pass the negative value minus 10, right? It's minus 10. Okay, minus 10, and you go up with the current I2. Okay, but there is the opposite current, which is I1 also. So we're gonna write I2 minus I1. You pass, okay, you go up right here. You are here. You pass the resistor of 10 ohm. Okay, you're gonna pass the resistor of 10 ohm right here. Okay, I2 goes up, and I1 goes down. So in the opposite direction, which is I1 is negative. We have negative in front of I1. I2 goes in the same way as the leading current. So it's I2 here, positive I2. It passes the resistor of 10 ohm. So we're gonna write down number 10 here. Okay, and you arrive at this location. Okay, where should you go further? You should go to the right side, right? Because this is the clockwise direction. Okay, clockwise direction. You go with I2 and you pass 6 ohm. I2 and 6. Okay, IR. And you also you pass this one. Okay, you go this way. You arrive at this. And you need to go downward, right? Because you need to go downward because this is the clockwise direction. You go with I2, you pass resistor of 4, so it's I2 and 4 and equal to 0. Okay, because you will reach the same point here. Okay. Okay, let's manipulate, or let's simplify this equation. This is negative 10. Okay, negative 10. And plus 10 I2 minus 10 I1. And plus 6 I2 plus 4 I2 equal to 0. You can see that this is 10 and negative 10 plus 10 I2 negative 10 I1 and plus 10 I2. Okay, we have two terms for that, but anyway, there is a common number which is number 10, so we're gonna multiply the whole equation 1 by 10, the whole equation.โอ้หมดเวลาแล้วนะครับเดี๋ยวขอจบข้อนี้ก่อนนะครับหมดเวลาแล้วนะอีกนิดนึงครับอีกประมาณ5 นาที 10 นาทีเดี๋ยวขอจบแล้วกันนะเดี๋ยวมันค้างนะครับข้างหน้าจะมาต่อ Okay, you multiply the whole equation, you're gonna get minus 1 plus I2 minus I1 and plus I2. Yeah, you would have 2 times of I2 because 1 plus 1 will be 2. And this is negative. We move to the right hand side. You're gonna get negative I1 plus 2 I2 equal to 1, and that's equation number 2. We have before the first equation right here. Okay, 3 I1 and plus 2 I2 equal to 1. Okay, if we subtract equation number 2 by 1, okay, equation 1 minus equation number 2, so you will get 3 I1 plus 2 I2 minus I1. Oh, sorry. I1 and plus 2 I2. Okay, equal to 1 plus 1, right? Will be 0. And here we have if you cancel each other, you're gonna get 2 I1 equal to 0 y 0ทำไมเป็น1 ลบ 1ได้อะ Am I stupid ผมผิดอะไรไหม sorry ผมผิดอะไรหรือเปล่าทำไมมันขึ้นอย่างนี้ or 3 I1 minus, right? Stupid. Oh, I'm stupid. My God. Right here. It's not plus. It's minus. Okay. It's minus. Sorry for that. Minus. Okay. So we cannot use the minus anymore. So this one will be plus. Okay, plus. And here will be plus again. Okay, we will get we get this one as minus. Okay, minus. So you plus, so 2 is number 2. All right. Okay. Okay. Yeah. It means that I1 is 2 by 2, which is 1 ampere, right? I2 is 1, and we will substitute ครับเดี๋ยวขอให้จบข้อนี้ก่อนนะครับแหมเสียดาย substitute I1 which is 1 ampere into whatever you want. Okay, let's say in equation number 2 we're gonna get minus I1, right? Minus 1 plus 2I2 equal to 1. So it means 2I2 will be 1 minus 1. So this is number 1. So therefore I2 will be 2 by 2 or 1 ampere. Okay, but it's not the answer. Sorry for that. We need to deliver the actual question quantities, which is capital I. And what we have before is this one, right? Okay, capital I1 is equal to I1. So it means it's right here, 1 ampere. Okay, 1 ampere. And I2 is I2, so it's also 1 ampere. And what about I3? I3 is the difference between I1 and I2, so I3 will be I2 minus I1, which is 1 minus 1, and it's equal to 0 ampere. There is no current flow at all. So that's it for this problem. I am late for almost 10 minutes. Okay, let's check whether the answer is correct or not. Okay, I1 is 1 ampere. I2 is also 1 ampere. So capital I1 is 1. Capital I2 is also 1. Capital I3 is 0. Okay, that's it for this problem. If you have any question, just let me know, and we're gonna quit the lecture right now. see you next week and please do the homework. Okay, whether you want the delta to y connection problem or you want to do the maze analysis like this. Okay, I'm gonna create the homework in Google Classroom.โอเคนะครับก็วันนี้ก็คงจบไว้เพียงเท่านี้นะครับการบ้านก็คือถ้าคุณอยากทำ y delta นะครับคุณก็ทำนะครับใน Google Classroom นะครับแล้วก็ถ้ารู้สึกว่ามันยากนะครับก็มาทำเนี่ยเขาเรียกว่าอะไรอะ maze analysis เนี่ยก็คือหมุนวนนะครับก็ไปเลือกโจทย์มาหรือว่าโจทย์ในแบบในเลคเชอร์ก็ได้นะเลคเชอร์โน้ตแล้วก็เปลี่ยนเลขเอาอะไรอย่างเงี้ยนะครับโอเคมากมีคำถามอื่นใดก็โปรดถามนะครับถ้าไม่มีแล้วก็จะหมดเวลาไว้เพียงเท่านี้นะครับพบกันสัปดาห์หน้าสวัสดีครับสวัสดีครับ YouTube อาจจะมีดีเลย์นะครับมีอะไรก็พิมพ์มาใน YouTube หรือว่าในไลน์กลุ่มก็ได้นะครับสวัสดีครับ